The two straight copper rods, which are connected by a piece of loose copper wire, complete a simple series circuit which will carry a large direct current. The loose wire is resting between the poles of a magnet. There's also an ammeter in the circuit. When the circuit is switched on, a very large current flows. The loose wire is then flicked out from between the magnets. Because the movement is sudden, it is sometimes called the catapult effect. If we take the magnets off and reverse them so that the magnetic field is reversed, and then rearrange everything else, then the wire is catapulted in the opposite direction. When the direction of the field is reversed, the direction of the movement is reversed. The diagram here shows a side view of the arrangement. The brown circle represents the wire, with the current coming towards us. The magnetic field around a wire carrying a current is clockwise looking in the direction of the current. Since it's coming towards us, then it is anti-clockwise. The field between the poles of the magnet runs from north to south. The fields between the two magnets interact. On the left, they both run in the same direction and reinforce one another. On the right, they run in opposite directions and tend to cancel out. The magnets are massive and are not free to move. The wire is light and gets flicked out of the magnetic field. The thrust takes it away from the strong field and towards the weak field, as the system tries to reduce the concentration of magnetic flux on the left. Notice that the field, the flux, and the thrust of the wire out of the field are all at right angles to one another. A rule which can help you remember which way is which is called Fleming's left-hand rule, where the field, the current, and the flux are represented like this. If you position your hand so that the forefinger represents the magnetic field, I'm sure you'll remember that the F in forefinger represents the F in field. And then the second finger is angled so that it represents the flow of current. Less easy to remember, but there is a C in current and a C in second. And finally, the thumb, which is at right angles to both those digits, represents the thrust. That is the direction in which the force acts. And of course there is a th in thumb and a th in thrust. None of this sounds all that scientific, and sometimes it's easier to remember the way the magnetic fields interact and produce the movement. Thank you for watching.